Hey everybody, it is me, Steve. It is April 24, 2019. Time is 7:30. It is 46 degrees Fahrenheit out, and it is Rant time. Today's topics, I thought about it because the last video is unconformities. What is an unconformity in geology? Basically, an unconformity is any place in the rock record where time is missing, some amount of time, all right? It doesn't, usually it's a significant amount of time. It's something we can physically notice in the rock record. Now, usually individual beds will have some amount of missing time in them. It may be an hour, it may be a year, it may be 100 years. But generally in geology, we aren't concerned with such small bits of time like centuries or even really millennia, like 1,000 years. No one really cares. All right. So anything above that, depending on your scale and how zoomed in you are, it may or may not be considered an unconformity. Okay, I'm going to get into that later. Hopefully this video will just be one video, but I may divide it into two because of length. So we're going to talk about the three main types of unconformities. Now, there are many different unconformities that can be lopped into one of these three, but these are the three main types. You have an angular unconformity, a disconformity, and a nonconformity. And I'm going to give a sub-example of each one of these, all right? But that may be part two, we'll see. Okay, so let's hit the first one. What is an angular unconformity? Okay, now the definition generally says horizontal rock that overlie non-horizontal strata. Okay, so you have level strata or horizontal, same thing, or non-horizontal. This red arrow is pointing to the dark line, which is the actual unconformity. An unconformity is a type of contact. All right, but it's a contact where we're missing time. There's some sort of some amount of missing time in the rock record. That's important. Now, that's going to come into this in a little bit. But okay, so you have an angular unconformity. The rock types don't matter in any of these pictures I'm going to show you. I drew these. It's just for demonstration purposes. You can tell here these rocks dip this way. These are relatively horizontal, but these don't actually have to be horizontal. This could have been, this would have originally been laid down horizontally. Then deformation occurred, it was tilted, then erosion came, formed the actual unconformity, and now you have horizontal layers on top, but these also can be tilted, say this way, or this way, it doesn't matter. They were laid down relatively horizontally, the younger stuff relative to the older stuff. That's what that means. Okay, so they're caused by erosion following tectonic activity, which I just demonstrated to you. Examples of this would be the Jacobsville Cambrian contact in the Upper Peninsula, which is exposed around pictured rocks in the UP. Now, the Jacobsville's Neoproterozoic, the Cambrian's obviously the oldest Phanerozoic deposits we have, but the angular unconformity there is subtle. It's really subtle. Like here's the Cambrian strata and here's the Jacobsville. It's like this. Your eye may not pick that up. And from a distance, since they're both sandstones, you may think they're the same thing and the unconformity may actually just be some sort of cross-bedding. That's why we get up to things, look at them and measure them and test things, because these eyes, they are not magical reality detectors. They make mistakes and misinterpretations, because you see with this, not with these, all right? And this interprets things, whether correctly or incorrectly, this still does it. Like there's been times I've gone to quarries and there'll be a carved out section and I see bedding and it's coming this way, and all of a sudden the deep part, it looks like an anticline or something forms. And then you measure it and you find out all the beds are the same orientation. Well, it's just my eyes, because I live in a 3D world, it looks to me like there's an anticline, but when I measure it, there isn't. It's just that rock is gone. All right, so that's why we measure things, and measuring things is important, not just going okay at things and moving on. That's not how we do it. But anyway, before I digress and before this gets too long. Okay, so we covered angular unconformities. Now we are going to do disconformities. Okay, these are parallel layers of level rock. As you can see, or horizontal strata, same thing. They are caused by erosion or non-deposition, all right? Usually subaerial erosion, and I'll talk about this here in a second, which can form hard grounds, corrosion surfaces, or geosols can mark these things. What you see here, like you see here, this would be a corrosion zone. So like this is a cross-bedded layer. We'll assume it's a limestone. And then this here, and what happened was after this was deposited, it would have looked probably like this bed. So this gets deposited, and all of a sudden, deposition, for whatever reason, stops. Now the seawater is still here above it, above this bed, and what it'll do is it'll redissolve some of the carbonate rock, and critters will do things in the carbonate rock that'll form this corrosion surface, this hard ground, due to subaerial exposure. And what we mean by subaerial exposure is it's exposed but at the bottom of a body of water, okay? It's not at the physical ground surface in the air, it's in contact with water. And then after a certain amount of time, probably 10,000 or 100,000 years, somewhere in that time frame, limestone or more carbonates become deposited again, and that disconformity becomes preserved. This type of hard ground here, okay, that right there, an example, that would be within the Silurian, between two series, between the older Alexandrian and the younger Niagaran series of, well, in Illinois, they're dolostones, same thing in Indiana, but they are limestones in some places. This is almost a worldwide disconformity. Now, these things, although subtle in the rock record, can extend not just locally, although they do, there's some that are just like within a certain area, to nearly global. And that's something interesting about the Silurian. We had very similar deposition going on worldwide. It's kind of a weird period. But anyway, that's a rant for another time. So let's talk about our third type of unconformity, our nonconformity, okay? A nonconformity is basically it's defined as between sedimentary and metamorphic / igneous rocks, but it could be between sedimentary / igneous and metamorphic rocks, something like that, or metamorphic. It doesn't matter. Basically, what it's saying is you have here, and once again, this is your unconformity. The red arrow is pointing to it. Okay, this is another type. Okay, basically here you have a crystalline rock, we'll assume it's a granite or whatever, and it has been eroded over time, millions and billions of years, and then a conglomerate gets deposited upon it, and then a sandstone, and then a shale. And over here, another way you can have is you could say you have a shale deposited, then an igneous intrusion, like in the lakeshore traps of the Copper Harbor Formation, come up, deposit on that surface, and then you get some sort of, just some sort of time elapses, and then you start to get clastic sediments on top of it, again, a sandstone and a shale. Now, that's basically what a nonconformity is, and this may be marked by some sort of hard ground or something like that, but it influences the sediments above it, and that's going to be important because, as you can see, the erosion, there's some what we call paleotopography on this that influences the intertonguing of the conglomerate and the sandstone in some of the bedding. Now, I'm going to do a second part of this because this is coming up on 10 minutes. We're at 8:47 right now, so I want to save that for a future rant, probably the next one. I may even record it right after this. I got time. So I just want you to know that these are the three type of major unconformities in the geologic, in geology. And we're going to talk about subsets in the next one. But anyway, that is it. If you have any questions or comments, please leave them below, and I hope you learned something.